One very important question for software developers and testers in practice is to know when they have done enough testing so that they know that their systems are now 100% bug-free and that they can ship it to their customers. This is a very long discussion and there are so many points of view on this, so let's discuss a few of them. And the first one is about this famous quote by Dijkstra, and he says that testing can show the presence of defects, but testing does not actually show their absence. In other words, this means that you may have lots of tests created by different strategies, but you still cannot be sure, or you cannot be 100% sure that your software doesn't contain defects. And actually, there's no test strategy that can achieve 100% defect detection effectiveness. Of course, tests will help us reduce the risk of shipping a buggy software, but it will never give us the assurance that the software is 100% bug-free. And this is a bit related to the fact that exhaustive testing is basically impossible. Just think about any real software that you use or develop. Are you able to exercise this software in all the possible infinite inputs? You probably cannot, and that would cost you too much time and too much money. That is simply impossible. So this means that testing is also about prioritizing which tests are more important than others, because you're not going to test everything. And when it comes to prioritization, one thing that we can think of is that bugs are usually not uniformly distributed. So this means that, for example, if you have 5 components in your system, the bugs won't be perfectly distributed among these 5. We may expect more bugs to happen in some components of the systems than in others. Of course, you should use this information to prioritize what to test. And when it comes to think about which test strategies to apply, and we're going to see different ones in these following weeks, like functional testing, structural testing, and etc. You really need to apply different strategies. There is this famous pesticide paradox in software testing, which says that any method that you use to find bugs still leaves some bugs behind. It is like when you're using pesticides. At some point, the pesticide you use won't be effective against insects, and you will have to try a different one. The same for testing. If you're always using the same test strategy, at some point your test strategy won't capture the bugs you need. So we definitely need variation. And software testing is all about varying things. We want to see how our software behaves when we give it different inputs, when we put the system into different states, when we test different paths of execution, different types of data, different environments, etc., etc. So testing is about trying different variations, which can be pretty difficult actually, because testing is also very context dependent. If you're testing a web application, this might be different, or the testing strategies you're going to apply, they might be different than if you're testing a rocket for NASA or a mobile application, for example. And of course, very connected to the discussion we had about verification and validation, having no bugs is not enough. We call this the absence of errors fallacy, because even if your software is free of bugs, it may still not do what the user wants it to do. So again, validation is very important. Indeed, understanding and finding how much testing is enough is very tricky. And throughout the course, we will discuss a few ideas on how to know where to stop. But this is definitely a big problem in the software testing area, which we are still looking for solutions.